hopefully this is going to be a review. But what's going to happen here is we're going to have graphs of first derivatives, sometimes second derivatives, sometimes the actual function, and we're going to try to make some conclusions about the actual function or the second derivative function based off that. I know we've done this generally earlier, but now we're going to get into it with more specific justification that you need to use. And should you run into problems like this on FRQs, this is the kind of stuff you're going to need to say and be able to recognize, okay? So starters, these are things we've talked about already, but we're going to be really explicit about it now. If the first derivative is positive over a particular interval, then the function itself is increasing over that same interval, okay? This shouldn't be new to you. There should be nothing new in this at all. But we're just making a clear distinction. When my graph is above the x-axis, that means the function is, with my graph of the first derivative is above the x-axis, then that means f is, or g, or whatever the name of the function is increasing over that same interval. Okay, so then if we flip this around, of course, if the graph of the first derivative is negative below the x-axis, then we know that f is, or the function itself is decreasing over that interval. So same thing, really. The thing that I want to add to this is the opposite direction works as well. Meaning, if we have a function that is decreasing over an interval, then its first derivative will be negative. Same as if the, so this is kind of an if and only if situation. If the function itself is increasing over an interval, then its first derivative will be positive. So that's what vice versa is all about. Again, these are things you already know. Let's talk about the second derivative a little bit and how this is impacted by that, because I think that's kind of important. Again, we're still really talking about curve sketching, right? And the relationship between the function, its derivative, and the second derivative, and what those relationships are. So if the second derivative is positive over a particular interval, then the first derivative is increasing over that interval. So again, so we've sort of shifted from talking about the function and the first derivative and just kind of slid it over. And now we're talking about the first derivative and the second derivative. So it's the same idea in relationship to each other. If the second derivative is positive, meaning if the second derivative's graph is above the x-axis, then the graph of the first derivative will be increasing over that same interval. And then, of course, the second one is just the negative and decreasing one, right? So that relationship between the function and the first derivative is very similar to the relationship between the first derivative and the second derivative. And can we get a vice 2? All right, so it's the same basic concept as what we just talked about with regards to the function and the first derivative. The same thing will be true between the first derivative and the second derivative. And understand that on questions that you might see, they're asking you to do analysis, or they're asking you to do a sketch. So for example, they might say, okay, here's the graph of the second derivative. Which of these graphs could be the first derivative graph? Or which of these graphs could be the function's graph? And you have to make the jumps from one to the other and in between. And so these things are powerful in terms of identifying what the characteristics are of this one and then how it relates to the first derivative or the function itself or the second derivative for that matter. And talking about how to just make justifications for it based on a graph. And that's what you're really doing in this 5.3. You're going to get graphs and you're going to be asked a bunch of questions about the graph, because ultimately what we want to be able to do is answer all those things for ourselves without somebody posing the question, to be able to drill down on those enough to get all the characteristics that we need out of it to be able to graph it, okay? Now, here's the other part to this. If the first derivative is increasing, then the function is also concave up. So we've been talking about the first derivative as it relates to the function. We've talked about the second derivative as it relates to the first derivative. Now we can go the other direction. If I know information about the first derivative, that can give me information about the second derivative, and therefore tells me more about the function, okay? So now this is not saying if the first derivative is positive. We're saying if the first derivative is increasing. So whenever, because we can have negative slope, but it's also increasing. We can have positive slope that is increasing. So we're not talking about positive or negative here. We're saying if the first derivative is increasing, then the function will be concave up. And then, of course, what's the next line going to say? Correct. Okay. Right. So if the first derivative is decreasing, and then the function is concave down, and of course, vice versa. So all of this information we're going to try to synthesize and try to be able to come up with the graph of the function, or to come up with the graph of the first derivative, or come up with the graph of the second derivative, based off, or a possible graph, I should say, and kind of analyze it that way. I'm not sure what page it's on. I'm going to take a guess. I'm going to go 109. Woo, 110. That's pretty good. I'll take that. 110. Now, I have condensed it down a little bit to make it fit. Now, there are, how many questions? There are, I want to say 7. Yeah, there's 7 questions. So we got the first 4 on this slide, and then the other 3 on the next slide, because I wanted to leave enough room to give my explanation, okay? So if you want to try, why don't you go ahead and try this, and then what I think is probably going to happen is you'll have to clean up your justifications maybe. Also keep this in mind. This is something that I've learned over the course of this year. In terms of intervals, if this was a FRQ, if this was a multiple choice question and they were asking you about this, the open versus closed interval, that whole thing does not matter. They will not ding you for that. They won't put, as a multiple choice question, they won't put one open and one closed with the same numbers. They won't do that to you. So when it comes to whether or not you make, well, I guess obviously it says open interval here. But on some of the other ones, I just don't care. If you make them always open, fine. If you make them always closed, fine. It doesn't matter. Now, this one I would make open because it says open, but give that a shot and then we'll go through them together. I think one of the things when we work on problems like this, you always have to be really careful about, like, which function are we talking? Are we talking about a function? Are we talking about the first derivative? Talking about the second derivative? It's labeled here for us, okay? So just make sure that we understand that we're talking about the first derivative. Okay, so how do I know when f is increasing? Based on the first derivative, how do I know? Yeah. Yeah. So when the first derivative is positive, right? So from -4 to 0, the first derivative is positive, and from 4 to infinity, since they tell us the domain is negative infinity to infinity, it's all real numbers. It would have been nice had they just done put a little error on there. That would have been nice. Okay, so in terms of what you should, okay, and again, you want the wording right. You could have said f is increasing over -4 to 0 and 4 to infinity because f prime is positive. You could have said f prime, and you could have used the mathematical symbolism greater than 0. How many of you had something like this for number 1?
I see.
Okay.
Well,
go ahead.
Why isn't it negative infinity 0? For like f is it?
Well, right here at -4, it's the first derivative is negative.
Because there's a graph of f prime that is not f. Oh my god, I did this whole thing wrong.
Oh. Yes, this is the first derivative. That's,
okay.
yeah, it's real important to know. Right. This is not f. This is the first derivative. Yes?
Do I have to write a complete sentence? Like I just started at my intervals. I didn't say f is increasing.
I would, yeah. I would. In questions like this, when they're asking you to justify, they're looking for you to be as specific as possible. And so whether it's a complete sentence or not, it needs to contain all of that information. Okay? Even the whole restating the question piece, f is increasing. Okay? And so as you work through that in your homework, I didn't give you that much to do. Just try to keep cleaning that up as we work through it. All right. Decreasing, of course, wherever the first derivative is negative. So now, Mara, here's your negative infinity to -4, and then from 0 to 4. And because f prime is negative. So basically, I used the same format, changed from increasing to decreasing, positive to negative, and of course, I had to change my intervals. Yeah. I would not say that, because that's making somebody have to make an inference about what you mean. Okay, so if we all understand that below the x-axis means that the values for y or f of x in this case are negative, but I would not trust it to the reader or the grader. I would be explicit. Okay. All right. At what x value does x have a relative minimum? What has to happen to the first derivative in order to have a relative minimum?
Has to cross the x.
Yeah. Positive to negative. So not just that it crosses the x-axis, it has to cross the x-axis in a very specific way. Because if it has to go from increasing to decreasing. So from positive to negative. And so the only place where, one, yes, it does have to cross the x-axis. Where it goes from positive to negative is right here. Positive to negative. All the other ones are negative to positive. Negative to positive. So the only place that has a relative maximum is where x equals, and that's what you want to say. Because it occurs at x equals 0 because f prime changes from positive to negative. From positive to negative. And again, you could have said greater than 0 to less than 0. That's okay. But I would not talk about above the x-axis, below the x-axis there. Okay? Positive to negative. And so then, of course, number 4 gets into what we were just talking about, negative to positive. So that's going to happen here at negative 4 and positive 4. Okay? So that's kind of what we're looking for there. I think it's interesting that they use two different terminology for the same idea. Relative max in one and local min for the other instead of being consistent. But they all mean the same thing. Okay? Questions about that now? Any other clarification? All right, let's look at the last 3 parts. On what interval is f concave down? What are we looking for here? Okay, concave down, so we're looking for what kinds of slopes here? Decreasing slopes, okay? So where are there decreasing slopes? So right here, from negative 2 to 2. So at this point here, it's going to decrease, decrease, and then it hits 0 before it starts coming back up again. So from negative 2 to 2, and what's important here is they tell us the horizontal tangent. So we can, what that's really telling us is the slope here is 0, the slope here is 0. So because the first derivative is decreasing on this interval, that means f will be concave down. Okay? Now, points of inflection. I left a little extra room because I'm going to give you 2 different explanations. And one of them may seem familiar to you. The other maybe is new. I don't know. But they're both completely acceptable. Since we know we're concave down from here to here, it's the same kind of idea. We're going from where it's increasing to decreasing or decreasing to increasing. And that's where we can tell when we'll have a point of inflection, okay? Not about the x-axis. Increasing to decreasing, decreasing to increasing, okay? So here's the one way to explain it. Because so right here at x equals negative 2, we are increasing, and then we get to 0, and then we start decreasing. And now we're decreasing, and then we go to increasing. And so because it goes from increasing to decreasing at negative 2 and decreasing to increasing at 2, that's why I know there's going to be points of inflection. Alternatively, you could express it another way. Do you guys know the other way to express it? Yeah.
F double prime of x equals 0.
Yes, but we don't have f double prime. Yes?
I was going to say that relatively extreme law.
Exactly. So if I look at the mins or maxes of the first derivative, that's also the same thing. We're saying it in a different way because that's what makes this, right? This is not, x equals negative 2 is not the maximum of the function, okay? It is the maximum of this function, the first derivative. Negative 2 is the relative minimum of this function, but it is not the minimum of f. So when we are given the first derivative, I can take the extrema of this function, and that's basically what this is, right? This is an explanation of that. And so alternatively, you could say f is going to have points of inflection at x equals negative 2 and 2 because that's where the relative extrema are located. Again, these two things are saying the same thing in a different way. Both are acceptable. Okay, know that, and whichever one you're more comfortable with is fine. Okay, is it easier to pick off extrema just by looking at it? Yes, but I think we can get into places of confusion, confusing the extrema of the first derivative compared to the actual extrema of the function itself. So just be careful there, okay? And then the last one asks, what interval is both decreasing and concave up? So if it's concave up, what has to be true? For f prime. It has to be increasing. Okay, so I'm looking at spots that have to be increasing. Okay, for here. But now, where is it increasing? And also, f is decreasing. If f is decreasing, what is this telling us? That the first derivative is negative. Okay, so when it says f is decreasing, that's telling us the first derivative is negative. If it's concave up, that means the first derivative is increasing. So I need to be somewhere down here, and I need to find out where it's increasing. And where is it increasing? Okay, so right, so down here, it's going to be increasing. Okay, but it's negative. And then from here on up, it's going to be increasing. But it's not all the way up. We got to stop here at 4. Right? Okay, so from negative infinity to negative 4, we have to make an assumption. Right? We have to make an assumption that this continues on. That's not a cyclical kind of graph. So from negative infinity to negative 4, it is the first derivative is negative, but it is increasing. And then from 2 to 4, it's negative and increasing. It has to stop at 4 because once we go beyond 4, now it becomes positive. Okay. So in your homework today, these are the kinds of explanations we're looking for. And I know that you sometimes have to be like, all right, which graph am I looking at? Which one am I talking about? Are they asking me about f? Are they asking me about f prime? Which graph am I even looking at? Am I looking at f prime or am I looking at f? So all of that stuff that you have to keep straight all the time when you're doing these problems takes a minute, okay? It's really important. It's really important to ask yourself, which function am I looking at, okay? Which function are they asking me about? So they're showing me what the first derivative is, but all these questions are about the actual function f. Now, at some point, they might ask us about the second derivative too. I don't know. Or maybe they'll give us a graph of the second derivative and relate that back to the first derivative. So it's really important to sort of go, where am I? What are you asking me? And what information do I have? Because if you can establish where you quote unquote are and what you're looking at, then that is going to create all kinds of confusion moving between all the different functions. So just take your time, make sure you know where you're at, because you can confuse yourself pretty easily.